recording? All right, what's your question?
So find the equation of a line with the given information.
Okay, so what's the information you're given on that one?
F of negative 19 equals to 14.
Okay.
And F of
Probably lowercase f. Dumb me. F of.
negative 2 equals to negative 17.
So that what have they given you actually? They've disguised it, but what have they actually given you? Sure, but what if... Yes, the x and the y, but easier said, they've given you what? 2 points. This point and this point. They've just disguised the problem we already did as this, right? 2 points, and it says find the line.
So it says,
what?
Write your answer in point slope form. If your answer is a vertical line, type your answer as x equals like no, and if the answer is horizontal, y equals.
Okay,
you
sure.
Find point slope form and slope intercept.
Perfect. So point slope form is that long equation. Y, I'm going to do a different color. Y minus y1 equals m. X minus x1. That's where we're starting. Well, crap. I can get a y1 pretty easy. We'll just pick. I can get an x1 pretty easy, but what I don't have yet is m. So I got to go over here and do that. M equals, there's a different formula that looks pretty darn similar. All right, so now we should hop over back to our points and label. Doesn't matter which one you pick. So x1, y1. Cool with that? Do you know how to do this?
No, because like for some reason, like when I was doing the equation, it wasn't answered.
Oh, okay. Well, then we'll do it, and then you can type it in and see if it gets it right. Maybe it's just a minus sign somewhere. I was feeling like you knew how to do this as we're getting closer to the answer. So we're going negative 17 minus negative 14, which is plus. You're right. Over. What?
It's just regular 14.
Oh, no. You're right. I don't know where I got that from. Thank you. Over negative 2 minus negative 19. That one was better. So that looks like negative, 31. 30 over, this turns into a plus, right? Positive 17. That doesn't reduce. Because 31 is prime, right? If you want the reason why. Okay, so that's your m, right? So now we're hopping over here for point slope, and we're going to say, which of the two ones are we going to use? Let's just use the top one because it happens to be the same labeling. Nomenclature, if you will. Naming scheme. Y minus 14 equals, I always put, when I'm doing the Iowa math stuff, I always put extra parentheses just to be safe. And then x minus, so plus 19. You want to try that for us and see if it kicks us back a right answer? This isn't on the review per se, but you want to type that in and see if it gives us the right answer?
I can't because it's like
changed.
No, because it's closed.
Oh. Yeah. You can't do it after it's closed? Well, that stinks. Can you check the answers after it's closed?
Yes, and that was the
Oh,
answer.
well, there you go. Sorry.
Because I typed it before and like it didn't work.
I'm sorry.
So I'm like, it's like
we can look at it and see.
After that, I was just trying. Wait, did I have to have the parentheses for certain ones?
I can look at the. You definitely have to have the slope not just on the x, but also on that.
I have parentheses for like on the x and the x1.
Mm-hmm. No, then you shouldn't have needed them for the. You're right. For the first fraction, it wouldn't have changed anything. I can look at it and see. I can actually look at your submissions. Remind me after class.
So I kept trying. I tried different. I guess I tried different equations. And it's just like.
Remind me after class. I can look at your submissions, and we'll see if any of them are like, yeah, that's right. I'll definitely go in and fix it. Or maybe it told
also,
you.
I looked at one of my submissions, and I think my last one. I think I put in the wrong. Like I actually typed 2.
Well, that's not my fault.
Yeah, it's really
All right.
But like for a different one, I did the same thing, but it didn't work.
We'll see. I'll look. Don't worry about that right now. Today, review.
Okay.
Cool.
Like the first one it was like the answer. The slope was 22,
Mm-hmm.
but it flipped it to 1/22.
Because it asked for a perpendicular line. Because it might have asked for something perpendicular, and that's why it would have flipped the slope.
Yeah.
So be careful with that.
Yeah, so that's why I got more confused.
All right. What are we looking at? What are we looking at that's like priority number 1 to practice before this test pops up? Yeah.
Can we do number 2?
Number 2?
Yeah, it's easy, but I still want to do it.
Fine. I wasn't ready. I need the snipping tool. There it is. Number 2. Hop down to the bottom. You should be able to do this one right there where it is on the review. This one's not going to take a lot of extra room, but it does take our brains. What the heck? Okay, well, hang on. I was going to say, it takes our brains thinking about left to right and bottom to top carefully. So, there it is. Boop. There's the problem. All right, use the graphs to determine domain and range. This is nice. This is nicer than using something else. Like equations are a little tougher, I think, especially for the range part of it. So, use the graph to determine domain and range. For domain, well, I kind of imagine, you don't have to do it this way, but I kind of imagine take your pencil and just run it across the thing. Which way are you running it across? That didn't work. Left to right, right? Just that's the most important thing to be careful with. Is take the line, take your pencil, and run it left to right, and say, where does it start?
There.
And what is that?
-6.
1, 2, 3, 4, 5. -6. And where does it end?
6.
Are there any little hiccups in the middle? Not really. Okay, and then we got to ask including or not including. I think so. Good call. So including looks like that? Cool. And for range, we do the same thing, but the only mistake that sometimes I see is starting at the top, because that's the way you read a book. We don't start at the top. We start at the bottom and work our way up. First thing you see, keep going. Last thing you see, 6, and including or not. Cool. Groovy? I did. All right. I'm not going to do the other 2. I'll let you do the other 2. Just be careful with those includings or not includings. It's a good practice. So, domain, I guess the notes there, if you've never done this before and you're like, I want to pass this test and I haven't done good at all. Domain, check left to right. Range, check bottom to top.
For B, would range be 0, 0?
Okay, so draw my line. Where does it start at? Starts at 0. Good call.
0, 5.
Yes. And which one does it include and which one does it not?
It includes 0.
It would be 0, 5 bracket no. For range right there, just since you said it already. 0, 5 bracket no. But I'm not doing all of those. I want you to have at least some to practice. And if you run out of things to practice, send me an email. Look up online, ChatGPT, CUDA, or go to the book. There's so many, or go to My Open Math and look for ones that look like these. There's so many resources to find practice problems. I can't just kill as many trees in the world as trying to save trees here by giving you one. All right, what else we got? What are some priority questions here? Number 6 is pretty tough, and let's get the toughest one of these, which looks like C. 6C looks the toughest to me. They're all good, but 6C's kind of got a couple things going on there that look almost scary. All right, let's see if this works this time. It doesn't. That used to work. The right click on my Surface Pen thing. I've got to use this mouse. Right? Find the domain of the following functions. I know I've got A highlighted right there, but I want to do C because it looks the toughest. All right. So you see the word domain. I didn't give you enough room there, but your brain should automatically think 2 words if you're in my class. Different class, you might think different words. Bad numbers. That's the 2 words I think. You want the math words? It's called domain. Anybody remember? It starts with an R? Yeah. You want the math words? That's it. But you want to get the problem right? Bad numbers. What numbers for X would make this bad? Okay? There's 2 things that can be bad. There's 2 restrictions that really matter right now. There's going to be one later down the road, but for right now, for us, for test, there's 2. Remember them? Number over 0 is bad. And a negative number in the square root. Those are the 2 bad things. So if we're doing C, I'm going to rewrite it just for fun. Can either of those things happen? Both. I think both can happen. It wouldn't change how we do the problem. They can both happen, right? So let's pick one to do first then. We're going to have to do them both, but let's pick one to do first. Square root's on the smaller one, so let's do it. So this thing, right? The square root, it can't be negative. How do we write can't be negative?
Square root of x plus 2.
Careful. The square root is part of the condition. The bad thing is happening on the inside. X plus 2 better be bigger than 0, right? So you were jumping straight to the square root. Be careful. The square root is what's making the condition, but it's not part of it. And then we should probably just fix that by doing one little thing. X is bigger than negative 2. And then we should probably, we'll wait on it. That's that whole condition. That's the whole square root condition. Check mark, we're done. That's the square root of a negative number condition right there. That's all you had to do. Okay? In blue, I'm going to do the other one, number over 0. How do we make that condition a thing?
So that's square root.
Okay. Plus 1. Better not be. I just gave you the answer. I'm sorry. That's the hard part I did for you.
X, so it's technically can never actually equal to 0 since we already, since we're the square root, X is actually always be greater than.
Dude, I got to find out for more clues. I'm not. Oh, you're right. We'll find that out in a second, won't we? Wait. That's a good thought.
Yeah, because like even if X is negative 2 plus 2 is 0, square root of 0 is 0, and then you just have the 1 remaining.
Yeah, that's a really good thought. Can this square root ever be negative? Square root's always positive, right? So can it ever be negative 1?
No.
Not really. That's part of that whole, remember when we did the first test and there was the square root questions, and at the end of the questions, that was the only one where it said check your solutions for those things called extraneous? That's kind of what we're about to see here. -1, -1, right? X plus 2, root, better not be negative 1. And then your brain would kind of be like, let's square it. But this is going to give us something that's not true. X plus 2 better not be 1. Right? So X better not be negative 1? Oh, well, that's okay. That's okay. We already knew that. Okay, I'm silly. But also, that's not even a solution to, although that's true and we already knew that. Wait, no we didn't. X is bigger than negative 2. That doesn't include that. Can X be negative 1? No, we got to. This is an extraneous from that one thing with anytime we introduce a square root. This is that extraneous situation. Because think about what you're actually doing here. Negative 1. Yeah, but I'm looking right here. Can X be negative 1? Really be careful.
Well, because if you make X negative 1, negative 1 plus 2 is just going to be 1.
And the square root of 1 is 1?
Yeah.
1/2?
Yeah.
So can X be negative 1?
Wait,
It
square root
can-
of 1 is 1.
it can be -1.
Yeah, it can. So that's what I'm saying. That's that idea of back in the day.
It can.
It can. I know it feels like it can't, but that's that whole thing when we draw a square root, and this hasn't happened before. This is kind of interesting question that we're getting is when we draw a square root for the first time, we have to check, which is what we did last time with the test. We just haven't seen it in a darn long time. When we draw a square root, you better check. We need to check, and we checked it, and I was thinking it was going to be bad, but it was actually good. So that's kind of cool. So -1's actually okay because we checked it. When you draw a square root, you have to check. It's the only type like that. That's a note from last test, and we're running back into it this test because maybe the homework just didn't put any ones like that on there. Because it could have very well happened that we got a bad thing when we plugged it back in. That was very, very possible. I think the situation would have been if that was x minus 2 right there. That would have happened. But, okay. So now we take both of those conditions. And we throw them on a number line. We take the condition that nothing happened over here because the only bad number we got was okay. So this thing kind of went away. There was no other numbers that were bad. So the only domain is x better be bigger than, if this is -2, just draw a big open circle there, and we go to the right. Forever.
So, actually, question. How can you decide if it's going to be open or closed?
You tell me.
Well, no, yeah, I know, but how do we determine if we put just greater than or less?
Oh! Boom, boom. Nobody stopped me earlier. Thank you.
Yeah,
They said he tried to.
Oh. That's why you should have said it louder. Y'all were saying it earlier?
You know, project your voice.
Yeah. No, yeah, absolutely.
Yeah.
But hey, to answer your question though, how do you know? Just plug it in and check.
Yeah, because you can, because I was like, wait.
You can plug it in.
Yeah, because I was like, wait, how do you know if you can put like just regular, less than, or greater than, or get to do less than?
If we want to be even cooler about this little bad number chart, if you want to be even better with this bad number chart, maybe from the beginning, I'll teach it next time. As soon as you see domain, you should think bad numbers. You should split it into 2. You should think number over 0. You should think negative square root. And then the very next thing you should think is you should think the denominator better not be 0. And you should think the discriminant or the thing under the square root. I don't know how to draw that. The number bigger than or equal to 0. Cool. That was a tough one because of all the weird stuff. There are 2 weird, one mess up and one extraneous solution. What's up?
Can we do 6A?
Yeah, we can do A because it's there. 6A is way easier. What's it saying? It's saying, yeah, read it for me because I just moved over.
Equals x minus 3 over x plus 1.
Way easier because we still have the 2 things to check, don't we?
Yeah.
Square root, thing on the bottom. I only see one happening. Thing on the bottom. So what's our big hiccup here, or big bad number here? X plus 1 better be not 0. Which means x better not be. Which means on our number line, what numbers are included? Literally every number in the world. Except for -1. So that's going to be that weird thing we always put in the homework module. Boom, 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 boom. We just get real good at typing it. Kind of like that. Right?
Yeah.
Way easier when they don't give you 2 things at the same time. I mean, and if you want to practically think about it in your brain, just look at the original. Yeah, that's what the highlighted ones mean. What? What don't you get? No shame in not getting it. How did we get to here?
Subtracted the -1, right? To the 0, that's why it's -1.
Oh, yeah, we did this.
Okay. So then it's just x doesn't equal -1.
Mm-hmm. And that's a good way to draw. X this way is how you draw x doesn't equal -1. You highlight everything in the world but -1.
On the other one, why was it less than Oh, that's
Because it was underneath the square root. Underneath the square root, bigger than 0. Underneath if it's on the bottom, denominator not 0. Those are the only two situations for this domain world we're working with. Is you either set the bottom not equal 0. That's a bad way to look at that. How can we say this? If you have an x on the bottom, so a number over x, this is what you do. You just go boom, 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 not 0, solve that. If you have a number in your square root, you go boom, 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 number bigger than or equal to 0. And you kind of, I'm not saying ignore because you don't ignore it in the problem, but the rest of that kind of goes away while you solve those two conditions. That's the kind of way to look at it right there. Number over x better not be 0. Something under the square root, you bigger than or equal to 0.
so because it's a fraction, you just put numbers.
Because it's a fraction with x on the bottom. If x is on the top, it wouldn't even matter at all. It'd just be a random fraction.
And the rest of the equation doesn't matter.
Nope, because there's no fraction and there's no square root. That's all that matters is that fraction idea and the square root idea. That's a good question. Domain's probably the most abstract thing we're doing this whole test is like random. It's not plug and chug, it's not solve, it's not anything, it's just this random thought where you have to remember two things. The rest of them are pretty solved, like plug and chuggable. All right, what else are we looking at? Anybody else got any? Anybody else? But thank you. What's up?
Like on the test,
Yes.
like it's not gonna have like a blank graph and then
Am I?
no, like and then like have like an equation.
Okay.
Where you have to, like, find-
If that were the thing, totally allowed. That is a totally allowed thing. That's a great question, though. If there were a blank graph, and what's the kind of equation you're like worried about? Like just a random like.
like I seen one on the review. It was function equals 2 minus the square root of x, and then like it ends plus like 1. And I don't know what that means.
Like that? Or more like this?
No, it was not. It was only a square on the x.
Like that?
No, it ended on the x.
Okay, well, if that's the thing, that's great. That's not too crazy. Because that's just going to be f of x equals, this 2 and this 1 get to get combined. That's why I was wondering if that's how it was or not. Because what's 2 plus 1? So 3 minus root x? Because that's that idea of combining like terms. If they have the same variable, same exponent, you can get combined. Different variable, can't combine. So you just leave it alone. Combine. But then your brain... Did we do transformations of functions? We did? Okay, so what is that? Ooh, this one's flip-floppy. You might want to move it backwards to where it's supposed to be. F of x equal negative root x plus 3. So root x looks like this. Negative root x looks like this. Plus 3 looks like this. Are there none like that on this review? Oh, there is. It's kind of right here. Oh, it's a little more abstract. This whole section right here is kind of, this is what we're talking about. Yeah. This is, if you're going to have one like that, it's going to look like this. Here's a graph, do the thing to it. But I'm not saying this is a very possible idea. That's like, thank you for saying it, because that's super possible. I don't see why it wouldn't be. And if you're scared that you did it wrong, just take a number like 0. 0 is the easiest one, and plug it in and see what happens. Even to the original equation before you messed around with it. Plug 0 in right here. You know that that's 0, right? I'm going to erase those so it doesn't look ugly. But so then you get 2 minus 0 plus 1 is 3. Does it kind of feel like this has 0, 3 on it? You got to know where 0, 3 is, but boom, 2, 3, boom. Kind of feels like it has the point 0, 3 on it. So we probably did it right because we checked the crucial point, that middle point. These don't help as much because, I don't know, they don't. So, that's not a bad problem. That's a good question and a very, no, I wouldn't say that that's off the table based on what we have in this review. Looking at those 3 above. But heck, if you get super stuck on a test and you have a problem like that, blank graph, you know what I would do? I wouldn't even do anything we just did. If you have any equation of any length, difficult as it could be, and a blank graph, you know what I'm plugging in? Any equation, any blank graph, I'm doing this right here. What are the most basicest 5 things you could plug in? 0, 1, 2, -1, -2. I'm plug and chugging. I'm not even trying to remember transformations back, forth, up, down, flip. I'm just going to plug and chug. Because honestly, the graph's only going to have a max of 5 on each side, maybe 10. So you skip every other one, you got 10 points to plug in. You did 10 plug and chugs max. That's not too bad. So, yeah, I would do, if I were taking a test, I'd do this. That's just me. And then maybe check it and say, does that look like it's a shift that I know is happening? Maybe. This is all in that shift section. That was kind of a tough section of the book. All right, what else are we looking at? Yeah, go for it. 8B. 8B. Can't just say all the highlighted ones. I don't know. All right, AROC. We got that AROC going on. When you see that word, average rate of change, your brain should jump out and say, this is almost identical, at least for our case. Yes, thank you, to slope. Now, is it exactly the same? No, it's got a little difference. But it's basically the average slope. So what's that slope formula? y2 minus over. Okay. Well, we've got 2 of those things, but we definitely don't have the other 2 yet. We're going to have to do a little bit of pre-work. Yeah? Plug and chug? So if we're doing B, I'm sorry if I didn't say that. If we're doing B, we're doing F of 1 or 3? Because I see a 1 and I see a 3.
3.
Yep. The 1 is just an indicator. It's not real. It's not in the problem at all. Equals root 3 times 3, which is what? This is a fun question I like to ask. What is this? One word, what is this? It matters. It matters that you see that and you know immediately, I know what that is. That's a, no, that's not a function. Hang on. That's a function. That is a function. This is a one word. It's not an equation. It's not a solution. A solution is a really key word that means something. It doesn't just mean answer anymore. That's not a solution. I don't know. That's why I said it's a fun question I like to ask. Because when I see this, my brain goes, oh, I've got a, but I'm not going to say it. What?
Can you give us the first letter?
No.
Oh, wow.
What are you saying? Oh, no, I think you were saying what it was. Okay.
Come on, don't doubt yourself.
It's one word. I see this and I think, oh, I know a, I don't know. Think. Not from the rest of the problem, just from what's on the screen zoomed in. I know all I know is one thing, pretty much. I know one thing from this problem.
Point?
Yes, I know a point. I don't know any other things, but I know one point. What's the one point I know? That's not the answer. That's just a point. Shh. Why didn't y'all say that way earlier? This is on you. That one's on y'all again. Thank you. Okay, what's the next one? F of 12? Root, I'm guessing it's 3 times 12. I'm not looking backwards.
Yes.
Root 36. 6, I know a point. The point is 12/6. And now with those 2 things, it goes back to the thing we did at the very beginning of the day, which is, can you find the slope? Could you find the line? Could you find a perpendicular line? All of the things that go with this thing. There's a million things that could go with it, but right now it's just asking for slope or average rate of change. So we are just going to plug and chug this. Let's call this the x1, y1, x2, y2. And go to town with 6 minus 3 over 12 minus 3 equals 3 over 9? Equals 1/3? Anybody else get that same thing? Dope. Technically, we're not writing m. This was in the section before we learned the m. Because it's not technically the slope of a line. It's the average rate of change. But if you were to write m on a test, I probably would circle it and give you full credit. I would. It's just the answer. Yeah. Or if you want to write average rate of change is, or AROC equals 1/3, or there's no. We learned this like way long ago before we even talked about slope or lines or anything. So. Yeah. Oh, this is what we started with. Let's do 5B just because it's the harder one. And if you can do B, you can do the other two. This is exactly what you were talking about, right? Earlier, Deb? This type of problem. Okay. Shrink. Boom. Using the given conditions, write an equation of indicated form. Oh, they didn't give us an indicated form. So we should do both point slope and slope intercept. Because it says indicated form. And I'm guessing on where I pulled this from, it also gave you two forms. So we'll do both. So passing through this, I'm going to call this x1, y1. And parallel to that. Oh, wait. No. I want to do B. Sorry. Passing through this and perpendicular to that. So what does perpendicular mean in 2 words? Flip, flip. Flip the sign, flip the fraction. If you want to remember the math words, anybody got those for $100? Negative. Same thing. Negative or opposite, if you want to call it opposite. What?
You're gonna start creating tabs for us.
What, to give you $100?
Yeah, you owe me 200.
I do. One day when I'm really rich, come and get it from me. That day is not today.
Yeah, after you
After you graduate.
So the original slope was m equals negative 1/2. So the new slope is new perpendicular m equals 2. Okay, that's not that bad at all. So we're going to do y minus negative 3 equals 2x minus 2. Because we got x1 from over here and y1. And that's our answer. Now, what if it said I want it in y equals form? Or it wouldn't say that. It would say slope intercept form. You got 2 works to do.
You have to
distribute first.
distribute the 2, which will give you
Y plus 3 equals 2x minus 4.
yes,
And then subtract the 3.
which will be y equals 2x minus 7.
Cool.
Wait, what happened with the new one?
With the what?
Like, is that a 1 right there in front of the M on the blue?
No, that is the symbol for perpendicular. So this is saying your new perpendicular slope. Your new perpendicular slope was flip. It was flip the fraction, flip the sign. So it became positive when it was negative. It became 2 when it was 1/2. Flip. The names of these matter because you want to answer in the right format. What's the name of this thing? And what's the name of this thing? Thank you. They matter. Because if the question asks you for a specific one and we screw up and write the other one, you'll probably get half credit, but not full.
Just write both.
Yeah, sure. No, if you write both, it's fine. Yeah, that's kind of, unless it asks you for one. If you write, I don't know. Just remember. Yeah. Yeah.
For insurance. They can't catch you up. You did for free.
You did put the right answer in the box.
You ain't wrong if you put low. So
All right.
So if it's parallel, you don't include nothing, right?
Parallel, same slope, right? Perpendicular, flip, flip. That's the only difference between the two types of problems. You just got your slope. No, we still have 7 minutes.
So for C, the negative 4 will stay.
You ready to leave?
And you solve it normally.
Mm-hmm. Do the exact same thing. You just don't have that blue step in the middle right there. You already know you're in. Everything else would be exactly the same. All right, we got one more question, then we'll take it off. We'll leave. Anybody know that you know is not here for rolls, so I can do it quick? Anybody that usually sits at your tables? I think so. Yeah.
I don't know people today.
All right. 10A. Oh, that's a good question. All right. Last one of the day. Finding this inverse thing. Now, we did have 4 long steps for inverse, but then I think by the end of it, we kind of just said if you can remember the one thing, you're going to be able to solve the problem. You remember the one thing that inverse means? Switch X and Y. Bless you. Now, there were 4 steps. Replace f of x with y. Switch them. Solve. Replace it back. Those were the 4 long steps. But if you can just remember this, I think you're going to be set to get the answer, I hope. So, let's write it. Y equals. Let's switch them.
X equals Y plus Q.
And solve.
So then you have to cube root.
Yeah.
Cube both sides to get the cube root of x equals to y plus 1. Subtract 1 from both sides.
Y equals.
Cube root of x minus 1.
And then we don't leave it there. We write it f invert x equals. Boom. Cool? Did it ask us to find the domain as well? Nope. Interesting thought here. Interesting thought that I just had, which kind of goes back to the little hiccup we had with that domain earlier. We had a hiccup with domain where it was an erroneous solution and it kind of hurt our solve. Is what if it would have been the exact same thing, but it would have said this. X plus 1 squared. Could you find our answer pretty darn fast? What do you think it would be? So you're thinking it's just going to be root x minus 1? Same thing, you just got rid of the cube thing?
Yeah.
Now, I posit that that's not true. I don't think that's true. Why is this bad? And this is a real good question to ask, and then we can end on time. Why is there something going on here that's pretty bad? Boom. This is the function we know and love. That's a parabola, except for shifted. What do you think? Left. Because plus and yeah, it's opposite of what you think. I got you. That's why I taught it that way, is because it's the opposite direction you think, right? So this whole question is asking about inverse, right? And they even give you this keyword right here. But guess what that is not? 1-to-1. So right away, even if you think you can get it, you can't. It's not possible. We don't know it. It doesn't have an inverse. What? Why would they? They might say that with a domain restriction of 0 to infinity. Because that function would look like this. And now it passes the horizontal line test. But for the most part, we can kind of think of parabolas non-invertible unless they give us some real wonky conditions on the side. So that's kind of just an interesting thought, is like, oh, the cubic function seems like it's more complicated. But actually, it's perfectly invertible, whereas the square is not. What's up?
Why did the 1 turn to a -1?
Because we were going -1. -1. Cancels that. You got y by itself. Then -1. We were just skipping steps. If you want the truth, we were like skipping a lot of the algebra steps. Don't copy me. You do the algebra. All right.